All right, so good morning. Let's start the first session of the day. I hope you enjoyed the previous days of the course. So we're going to start today with Angular security, or building secure Angular applications. I have a couple of topics for you during this talk. I'm going to talk about cross-site scripting, content security policy. I'm going to talk about client-side session management, and a couple of words about JOT tokens and how you can handle them in a more or less secure way. First of all, does everybody here know Angular? Who doesn't know Angular? Okay. I have a 10-second Angular introduction, so that will definitely help you. But most of the material you'll be able to understand without really knowing the ins and outs of Angular. So maybe one important thing is to highlight what has changed with these Angular applications or Ember applications, essentially client-side JavaScript applications. So you used to have this server-side software which generated HTML, pushed it to the browser, and the browser simply rendered it. Maybe there was some JavaScript in there, but it wasn't really an application. It was a page, and it did something. With an application, when you have a browser and a server, essentially you have some Angular code, or Ember, or React, or whatever. You have some HTML code, and you have a database somewhere, probably an unsecured MongoDB, something like that, sitting on the web. What happens is, first of all, you load the application, and you get all of this code. But that's once this is loaded, you have an application running in the browser. So you have actually this JavaScript application which uses HTML templates to render some content for the user. So instead of getting a full page from here and showing it here, you actually get an application and you start fetching templates to load them in here. And if you have some data, you actually have placeholders in the template. You have in the template, you can do data binding. You can say, I want to bind this piece of data right there in the template. And then you fetch the data afterwards using APIs. You get the raw data, which is in a JSON format or whatever, and you simply inject it here into the template. And that's how you build applications. And if you want to change something, if this is a table and you want to sort it, you simply click on it, and it sorts itself. All on the client side, all in JavaScript. Previously, you used to go back to the server, ask the server to sort this table for you, get the table back, and render it again. Not with client-side applications. If you want to add data, what typically happens is if you add it here, the UI updates instantly. You see the new item being added to your table, and in the background, the JavaScript application will push the data to the server, ask the server to store it, and if something goes wrong, it will recover afterwards to make sure this is okay. Jim already asked me what kind of Angular version you're going to talk about. This is important because we used to have Angular 1, AngularJS, but since about a couple of months, we actually have Angular 2. And we almost have Angular 4, and it's going to go on like that. So they're going to skip Angular 3. If you want to know why, look it up online. There's plenty of documentation there. Essentially, Angular 1 is the old Angular. It's the original framework, and everything above that is the new version. They're not going to use slow versioning. They're going to have quick updates, have version 4, 5, 6, 7, so it's going to change very rapidly. But the changes are not going to be breaking, while the changes between 1 and 2 are more or less breaking. So that's all I'm going to say about that. So the 10-second Angular tutorial, I actually stole this from the official Angular tutorials. So what you want to know is you have a template. So you have HTML code somewhere. In the HTML code, you can have elements, like an input element or a button, and you can give Angular directives about what it needs to do with this. So you can tell Angular that this the value of this input element needs to be bound to this variable called foo. And by doing that, you actually will create a variable in the controller somewhere with the name foo, and you will be able to use that somewhere else. You have controllers. In controllers, you can keep information. You can perform operations. You can contact services. You can start making ask a service to make a background call to an API, stuff like that. So this is a JavaScript application. This is a template. Note that there's no data in here. So button text is some text that needs to be shown on a button, but this is a variable name. This is not data. That data comes from somewhere else. It could come from the controller. It could come from an API, whatever. And then maybe a final thing, which is what makes things like Angular so powerful. You have the capability of defining custom elements. So you can define something called hero detail. This is from the heroes tutorial, which essentially renders some HTML that the browser understands. The browser doesn't understand hero detail, but Angular does. So Angular runs in the browser context. It looks for these kind of things and does whatever needs to be done when it identifies one of your custom elements. So that's what Angular is about. In 10 seconds. That's about me. You all know who I am by now, so this is mainly for the people finding the slides online so they know who made them. So let's go on to the first topic of today. I have 5 key points during the presentation, things you should really remember. I'm going to recap every one of them after I've explained them. So if you only want to pay a very short attention during my presentation, be sure you get these takeaway points. The other people can follow the whole story, of course. So cross-site scripting. What is cross-site scripting? Very brief introduction without going into too much detail. If you went to the OWASP talk yesterday, you got the full introduction from Jim. But essentially, cross-site scripting, in such an attack, malicious content is injected into your page. So to give you an example, if you have a search box and you enter a search term with a script tag and that happens, you are in trouble because this tag has been put into the page and rendered by the application. Content can be anything. It can be JavaScript code, HTML, SVG, CSS, stuff like that. And in a bit, we'll see that you can also inject Angular code and do some nasty things with that. Why is cross-site scripting such a problem? Not because of alert boxes, but because of things, all the attacks that you can do with it. This has been covered before. Once you have code running in the origin, in the context, you can do whatever you want. You can start stealing webcam images if these permissions have been granted. You can social engineer the user. You can steal cookies. You can do plenty of things. To talk about Angular, well, cross-site scripting in Angular, we should actually take a step back and go back to these old applications I mentioned before, these PHP applications. So if you have this very small snippet of PHP code, you echo a username. Well, if you know a bit about cross-site scripting, you see that this is probably not going to be a very good idea. So if you have a URL like this with the username Philippe, this code will will result in this. If you put some HTML in there, the HTML is actually outputted right here. So if you put some script in there, at this point, this is the beef hook. At this point, you're probably in a lot of trouble. Doesn't look too bad, but in the background, your browser is compromised and the attacker is running code in this context. And that's cross-site scripting. So in a nutshell, untrusted data, something from the URL in this case, controlled by the client, ends up in your HTML and compromises you. How do you defend against this? Again, Jim did the full XSS talk yesterday evening, but in a very brief nutshell, what would suffice here is to encode this for the HTML context, which you do like this. So when you do it like that, actually this comes out and you're good to go. So that's in XSS defense in a nutshell. The problem is, this looks simple enough, but in reality, a PHP page has hundreds or thousands of these outputs. So you have to do it everywhere, and you have to do it for the right context. So that's a very important distinction with this output encoding. It needs to be context sensitive, meaning here it's for HTML, so you should filter out script tags, which is okay in this case. But here, it's in a JavaScript context, here it's in an HTML attribute, and here it's in a CSS context. So all of these contexts have different requirements, and you need to make sure that you filter out the appropriate things. Yes?
Seriously, Doctor, I just heard you say filter out script tags, which...
Sorry, encode them, thank you. This is not sanitization, it's encoding. Thanks for the slip up. I only had one coffee here today, so that's probably the problem.
I'm still amazed by your intellect.
So, if you look at this, this actually looks very familiar, and this was mentioned during the OWASP meeting yesterday as well. If you look at code like this, essentially what you have is you have a problem of mixing data with code, and that problem exists in other places as well. So we used to have things like SQL injection, where you actually mix a part of the SQL query, which is code, with data coming from the user, resulting in something like SQL injection. So essentially, the same kind of principle applies to cross-site scripting. Once you're able to separate data and code, you're actually able to protect against cross-site scripting, which is essentially what happens in an Angular application. Because in an Angular application, you have your code. You have your HTML template with data binding. You know exactly where the data will be inserted. So once you do this, you have a username again with some script tag. Angular will make this for you. It will automatically encode the input for the right context, because Angular knows I'm going to put something in between this HTML tag, so this should be encoded for HTML. It's data, so I don't want any code in there, so let's make this out of it. So automatically, Angular does this for you. Same thing for these other scenarios. But what if you really, what if you want want some HTML in there. What if I actually want to allow the blink tag, but not a script tag? That's where things become a bit more tricky. So a few words about what Angular actually does here. So Angular helps you separate data from code. And actually, Angular helps you give or enforce this very clean coding style, which you should have been doing from the beginning, but nobody ever did. So that's definitely a good thing. What Angular does is apply this concept called strict contextual escaping. And that's where they look at the context that you're going to put data in, and they apply the right escaping for that context. Just like that, instead of you having to select the right function from this encoder library, Angular does that for you, which is very good. This applies to everything you bind with these double stashes, or ng-bind. And this is enabled by default since 1.2, which is essentially an eternity in the lifetime of Angular. But again, what if you actually want to allow some HTML? Well, there's an option there. You can actually use ng-bind HTML, which sounds pretty good, right? It's ng-bind, but for HTML. But if you try to do that, if you have an input here and you output it here in this div with ng-bind HTML, Angular 1 actually borks on you. It gives you this huge error saying that, no, you're trying to use an unsafe value in a safe context. It just doesn't say bad developer, but that's what it comes down to. So essentially, it knows that you're trying to do something that's not going to end well. It knows that this is a potential cross-site scripting attack vector, and it says, please don't do this, do it the right way. The problem is, it doesn't say what the right way is. The problem is it gives you an error. What happens when you get an error? You go to Stack Overflow. Of course. And on Stack Overflow,
Then you're done.
yeah, then you're done. Of course, because it has all the answers. So on Stack Overflow, it says, this is indeed a problem. You need to sanitize the data. So if you remember Jim's talk, sanitization, that's awesome. Sanitization is very good. So yes, let's sanitize the data. Thank you, Katie, for the advice. So you have the sanitize filter. So whatever needs to be sanitized, you pass it through here, and you can bind it to ng-bind HTML. Awesome. If you do it like that, everything will work. You will see your blink tag until a bad guy comes along, and he will be like, what if I put script in there? And you're screwed. Yeah.
Do you need to specify pipe sanitize in Angular 1?
This is a custom filter, so you need to implement this filter yourself. Then you can specify that.
I should.
Yeah.
That's not how Angular 1 works, though. You just use the SCE engine. It does it automatically when you use ng-bind HTML. I don't think you need to call sanitize explicitly.
Yeah, you do. If you don't, you actually get this. If you don't, well, I'm going to come to that. I'm going to explain in 2 seconds what you need to do. But if you try to use ng-bind HTML automatically, you get this. I know because I tried it out this morning. So
which version? It's
this.
Angular 2, not 1.
Yeah, it's Angular 1.
Okay. You're in 1.3.
Yeah, whatever.
Oh.
Every Angular 1 version does this. But ask me again in 2 seconds.
You got it.
So what's really happening here is you define this filter, you call this SCE service, you say trust as HTML, and you have some HTML code, and you're done. But if you start to investigate this advice, if you look at the documentation, which no one ever does, but let's say for the sake of argument you do, you'll find some explanation about this SCE unsafe error that you get. An SCE unsafe error, as you start reading this, essentially what it says is this is strict contextual escaping at work. It's protecting you against these problems, and you should use the sanitizer. You should use NGSanitize, but it's a separate module, and you need to include this yourself. And what you actually did, or what this filter actually does, the trust as HTML, if you look up the documentation for that, it actually says that it will mark a string as explicitly safe. So it will tell this SCE service that this string is considered to be trusted, and it will not trigger these errors anymore. That's why this filter, if you implement it like this, works, but also allows script tags, because you just told Angular, I don't care what's in here, I vouch for the security of this, and I allow you to do that just like that. And that's problematic. For the record, and I'm not sure if the slides is in here anymore. It isn't, but for the record, this Stack Overflow post is a couple of years old. Since then, I've talked about this plenty of times, and people have actually started correcting the answer. So the answer now has this note like, don't do it like this. You should use this NGSanitize module. So let me recap that for you. So this is where you pay attention, Jim. Angular 1, by default, escapes your data. So if you have something like this, SCE will be applied, and you will get encoded output. So no cross-site scripting there, which is actually very good. That's a default scenario, so it covers most cases. If you want to use HTML in the output, AngularJS 1 will not allow you to do that. It will simply give you this error that we saw before and say, don't do this. If you want to do it, you should include this module called NGSanitize. This is a separate module. You load the dependency, and from then on, Angular will automatically apply the sanitizer to this ngbind HTML. So that's the point where Angular 1, the sanitizer kicks in, and it will effectively start protecting you. It will filter out the script tag and leave everything else untouched. And that's a good scenario if you want to output some HTML. And if you really must do, you can use the trust as HTML, but it's only meant to be used for things like this. If you want some quick template output and you want to write it yourself and there's no user input in there, then you can use it. Then you can mark it as safe, but all other cases are essentially a no-go for these things. Does that answer your question?
Yes.
Yes. So
I just believe there's a way to do it automatically without needing to call the filter. That's all I'm trying to say. And I'm splitting.
Yeah, no. The filter is it's bad advice. The filter is not necessary. What's necessary is the NGSanitize. Without NGSanitize, without loading the sanitizer, you will get the error. You will not get the sanitization.
You're completely on the same page, and I would be better to pay attention to.
Thank you. You're going to learn a lot during secappdev, so it's great. So Angular 2 is even better. Angular 2 does sanitization by default if you bind to this inner HTML attribute. So this essentially tells Angular, I'm going to bind some data to it. Angular knows that inner HTML is like a big no-no, so it's going to apply the sanitizer automatically. So again, the blink tag will work. Well, actually, I haven't tried whether it allows it, but let's consider it to be non-malicious. It will work. Script tags will be filtered out. So in this case, you will not get a script tag in the output because the sanitizer has taken this out. So that's definitely a step forward because it avoids you from getting these errors and starting to Google for it and finding wrong fixes. So it's a more secure position by default, even though the protection applied here is essentially the same as the sanitize module in Angular 1. So the sanitizer is definitely very important. There are a few, well, Jim has mentioned this before. If you do Angular, you need to keep these things in mind and stop doing very crazy stuff. So don't directly call DOM APIs. So you can, if you really want to, you can access DOM APIs and start binding data directly. Don't do things like that. Stick to the Angular way, and it's going to cover your XSS attack vectors for you. In Angular 2, you can also use these trust as HTML functions, but they made a small modification to it. They added the keyword bypass security. So this hopefully helps people from writing these sanitized filters that call trust as HTML and hopefully triggers a bell like, bypass security, what could that mean? Maybe I should read some documentation on this. You might think this is sufficient. Unfortunately, you'll find posts like this on Angular 2, the Angular 2 GitHub project of people trying to turn off the sanitizer because they know how to protect against cross-site scripting and they don't need it and it gets in the way. Actually, you should read this thread. Well, I've redacted the dangerous parts because you shouldn't be doing this. But actually, security people from Angular start arguing with this guy and he's like, no, I know how to do it. I don't need it. I want to disable it. So it's actually quite a funny thread, but also sad that he still believes that he knows better than these security guys. So, takeaway number one. If you were still groggy from waking up early this morning, this is where you need to pay attention. Angular protects you against cross-site scripting. You only need to get out of the way. This means that if you do it right, if you use Angular ways, it will automatically escape this data for you. You can bind data that results in HTML code, but you need to use NGSanitize in Angular 1. Very important, not a sanitize filter you find on Stack Overflow, or use Angular 2 where this happens automatically. And then third, if you use this trust as HTML function, be aware of what you're doing and only use this for static data that you know that is actually secure. Only use it for quick template injection and not for loading some user-provided data. That's very, very essential. And if you follow these basic steps, I'm pretty sure that most of your cross-site scripting attack vectors in Angular applications are addressed correctly. Any questions here at this point?
What exactly is the relationship between Microsoft and Angular 2 and the rest of the consortium? Is it being taken over for the most part?
Thanks for that very relevant cross-site scripting question. I have no idea, honestly. As far as I know Microsoft has well, they're actually providing a lot of great tool support for building Angular applications. So they have support in Visual Studio. They have the Visual Studio Code, which is used a lot by people. They're also involved because of TypeScript. So Angular 2 uses TypeScript by default, which is a project created by Microsoft. But I'm not aware of any, well, as far as I know, the Google team is still fully in charge of Angular. So,
Yeah,
but
I mean,
that
it's a collaboration. Have you used the Node tools for Visual Studio or VS Code? It's fantastic stuff.
okay. I haven't checked it in a while. So I hear they have very awesome code completion and stuff like that now.
Yeah, IntelliSense that they, give you they can automatically generate TypeScript or have people that mark up the libraries and most common stuff. So most common modules you get full IntelliSense. And,
Yeah.
it's pretty interesting. They do speculative typing.
Yeah. So if you're doing Angular and you're still using Sublime or something like that, check out Visual Studio Code. It's freely available.
Lightweight.
It's lightweight. It's actually a web application.
Yeah.
It's pretty awesome. On the Electron, yeah. So yeah, definitely check it out. Yes.
Just think of the future of Langsec for Angular. Why does Angular require that you mark something as being safe or unsafe? Is there a way in JavaScript to do taint tracking so that can be more automatic for Angular to be safe? Forgive the speculation. I'm just saying that's a fragile part of Angular. The moment I need a developer to start manually flagging things based on tainting, that's a dangerous path always.
Yeah, that's a good question. I'm not sure about that. What's very good about the fact that marking something safe can only be done in very specific ways. So you need to call these functions from the sanitizer service, and these are easy to check against. So you can easily check your source code whether a developer uses these things. You can integrate these checks in your build process, in your unit testing. You can check the code when somebody commits something. Does he use trusted HTML? If so, he has to answer why he's doing that and whether it's a good way of doing that. So that helps. Maybe Ian has something to say about that.
I was just going to say that, it's certainly not sufficient, but changing the namespace to reflect what the API does is really important.
Yes, absolutely. I think they never imagined that people would start using it regularly to mark something as safe. So yes, it's actually a step in the right direction.
Are you familiar with the DAO, the Ethereum Corporation bug that,
No. All right. So let's move on to part 2. This is still very closely related to cross-site scripting, and is actually a lot nastier than the stuff we talked about before. So Angular compiles its templates. So this means that when you get a template in the browser, Angular starts looking for these double brackets and these directives, and it starts doing whatever Angular does, which is pretty cool. But it also is pretty problematic in certain cases. So what can go wrong here? Let's go back to our PHP application. So you have this behemoth of an application sitting there for 10 years, and you need to maintain this, and you really hate PHP and writing PHP templates and whatever. So you want to build this Angular front end for it. You want to use Angular to make your PHP application a lot more attractive, which happens a lot actually. So what you're going to do is you load your Angular library somewhere in the page, and you do your XSS protection, and everything is pretty okay, right? So you'd have some server-side output here. You put it in the HTML page, you give it to the browser loads Angular and starts doing whatever it does. Sounds pretty slick. Until somebody comes along and he says, yeah, my username is Philippe, something, something. And then this happens. And if you look at this a bit more closely, what actually happens here is you're telling Angular, you're giving Angular, this is Angular code. So you're giving this to the client. Angular picks this up, sees like, ooh, this is a double bracket. I know what to do with this. And it starts evaluating this. And this is one of the bypasses in Angular, which allows you to break out of the Angular environment and get access to the window object, meaning that you can call alert. And when you call alert, something bad happens. And when you can do this, you can do anything. That's essentially what it comes down to. And what's really happening here is that even though you as a developer did everything right, well, except for one thing, you did your best effort. You used the full XSS protection mechanism here. But the server, PHP, has no idea that a piece of static data, which is no script tag or something like that, will result in cross-site scripting when this library is loaded. And there are plenty of crazy examples of stuff that you can put in there that will result in script execution because of Angular being present. That's the only problem. The server doesn't know that this is dangerous, and he cannot know. And this is the same for Ember, and it's the same for all of these JavaScript frameworks. They all have their own specific piece of static data that will result in script execution. So that's a problem.
But can you go back to that example? But that's bad code, though. They're doing HTML entities against username instead of doing full encoding, correct? If username was properly HTML encoded, could this problem go away?
But this is not dangerous in the HTML world, right? This doesn't mean anything for...
It's the ability, oh, I see. So do our encoders need to handle curly bracket to be more complete?
No. People shouldn't be doing this. That's essentially the lesson here. But I'm coming to that.
People should be doing what?
Ask me again at the takeaway, and we'll see.
Doesn't HTML entities have a buffer overflow in it as well? In PHP?
That is very possible. I don't know. So this is definitely a problem. Why? Because the server doesn't see this as problematic code. It's not HTML executable. It only becomes executable because Angular is there. And it happens on the client side as well. So Angular has this order by filter, which you can use to order a table. So you can simply give it a string. The string matches a field here. And doing it like this, actually this is reverse order and the name of the field. Angular will sort the table for you. This becomes a problem when this field is no longer static, when you make it user controllable. For example, if you want this URL where you allow sorting by a field, so you can link to it directly, this will become a problem, because if somebody gives this as a sorting field, this string will be put in here, Angular will evaluate this using the parse function, and all of a sudden you have a script execution attack. This is covered by some guys from Synopsys, by the way, in the blog post, so if you want to read more about it, it's definitely worth reading. And this is a problem. Why is this a problem? Because you're putting untrusted data into a part of the application which will be compiled by Angular. It will be processed by Angular, and Angular doesn't know that it shouldn't be executing this. Actually, they tried to learn Angular. Well, there are plenty of ways to do this. So this is the problem I described here. It uses the parse function, but you have the compile and the interpolate, and you have plenty of these. You have the order by filter. So there's plenty of ways to achieve or to trick Angular into processing some user-provided content and result in security problems. By the way, this is from the security documentation of AngularJS, so it's documented, but it's still possible, and when it's possible, people will be doing it. They actually tried to prevent this from happening with a sandbox. This whole project started by Mario Heiderich, German guy. He found all of these ways to bypass these frameworks, and the Angular security team was like, okay, this is definitely a problem. Let's try to build a sandbox so that you cannot break out of it. So doing constructor, something doesn't do anything. It will be prevented. And they actually built this in, I believe, 1.2. It worked for like a week or two, and then they found a bypass, and then they patched it, and it worked again for a week, and then they found another bypass. And essentially, this kept going on for a year and a half. And every version of the sandbox is bypassable. So you can find code snippets online, most crazy combinations of Angular code that will eventually break out of this sandbox and still allow you to execute this kind of code. So essentially in version 1.6, they said, okay, this code of the sandbox is really horrible to maintain. It's really problematic, and it doesn't work anyway because people will still find a bypass. So we're going to take it out again. So in Angular 1.6, they took out the sandbox. So there's, again, nothing stopping you from doing that, so you need to apply good coding practices to avoid that from happening. Angular 2 has a bit better news. They offer something called ahead-of-time compilation. First of all, ahead-of-time compilation essentially compiles your Angular application, already compiles all of your templates into JavaScript code, and ships that to the browser. This is, first of all, a major performance improvement. So you get wicked fast applications, that's one. And the second thing is, because the template is already parsed, when there's no user data available, already processed, this attack factor kind of goes away. Because when you inject the user content and you ship the page to the browser, the template is already compiled. There's not even an Angular compiler in the browser anymore because it's simply not needed because everything is already done at that point. So this is definitely a good way to prevent it. And if you go look at one of these compiled files where you would have this data binding that would be vulnerable, at this point it's already fully processed, and essentially you again separate data and code in a very nice way to prevent these kind of attacks from happening. takeaway point number 2, never pass untrusted data to the compiler. This is the Angular compiler, which processes the templates. And this is essentially only achievable with good coding style. So if you combine Angular with these things, you're in trouble. You also have the same problem with client-side libraries. If you have jQuery running before Angular and jQuery does some crazy stuff like injecting Angular code, you're again in trouble. So in Angular 1 applications, never use it like this. This is, well, essentially it's the only thing you can do against this. Don't combine PHP with Angular. If you really want to do that, then load your templates and then afterwards load your data, but don't combine them on the server because that's not going to end well. And in Angular 2, you can use this ahead of time compilation, which essentially helps you protect against these kinds of things. All right. On to the next topic. So we've been talking about Angular specifically about cross-site scripting, but there's another cross-site scripting defense that you can use as a second line of defense, and that's called content security policy. We've talked about CSP before. And CSP is essentially a browser security policy. It's been around for about 3 to 4 years. That gives you control over what's allowed to load in your page and what kind of content is allowed to execute. So you specify the policy from the server. You set this header with a certain set of directives, and the browser will enforce that for you on your page. So if you set a policy like this, script src self, what will happen is the browser will apply 2 restrictions. First of all, it will only load external scripts, so script tags with an src, if they're whitelisted. Self means own origin, so the origin of your website. There's nothing else in the whitelist, so evil.com is definitely not whitelisted, so this script will be blocked. Browser will give you an error saying, I tried to load an external resource, it's not whitelisted, so I'm not doing it. Second thing CSP offers you is it prevents inline scripts from being executed. So if somebody would inject this script block here, it's inline script. It's because the code is right there between the block. CSP disables this by default as well. So by default, once you enable content security policy, these things are gone, and this needs to be whitelisted. So essentially, most of your XSS attack vectors are handled with. Think about a PHP application. What do you have in your pages that you generate there? Inline JavaScript. You have it everywhere. You have these things like on-click. You have these things like code between script blocks. So it's going to be messy to enable CSP on an application like that. Essentially, that's what happened as well. I'm going to talk a bit more on that Friday in my talk on client-side security policies. But what about Angular? We're here to talk about Angular. So what happens here? I have a code example. This is a very small example that doesn't really do anything, but it helps me show my point of CSP. So if you enable a policy like this, you see you have some script tags here. You have an inline script block here. So essentially, if you enable a policy we talked about before, you get these errors. And these errors essentially tell you, I didn't want to load the script from Cloudflare because it violates the CSP policy, and I don't want to load this inline script block because it violates the CSP policy. So let's whitelist it. Add the CDN to your whitelist, and poof, your scripts here are loaded. The inline script block is still blocked because, like I said, CSP prevents this from happening because there's no way to tell whether this is something you wrote or the attacker wrote. This is essentially CSP version 1. This is the version that has been around for quite a while. People found out, yeah.
Do you think it's a bad idea to whitelist the whole CDN?
Probably, yes.
Yeah,
This is a bad idea.
Binary data of each other's websites to each other.
Yeah. Host-based whitelisting is a bad idea. Absolutely. It turned out, well, people actually did it. Why? Because here it's 2 files, but a lot of websites require 10, 15 files. And then you simply, whatever, whitelist the whole Cloudflare CDN, and at that moment, you're probably in trouble. Again, more on this Friday. So this is research coming from Google from last summer. They actually investigated CSP policies, found all kinds of bypasses, which include, funny enough, whitelisting a CDN, which allows somebody, for example, to load an Angular library, then inject some of these curly bracket statements into your applications and run scripts through there. Again, more details Friday. But essentially, whitelisting doesn't work. They found that in most CSP policies, you can bypass the whitelist through some funky bypasses, of course, from the German guys, amongst others. So definitely there is some problems there. The reason I'm talking about this is because there are fixes for that, and that's what Google's work was about. The first fix is you should use nonces instead of host-based whitelisting. So a nonce, you generate a random nonce. Super random is not very random, but it's a random nonce. You put it in your CSP policy, and you put it in your script tags, and that essentially tells the browser, I mark these script tags as trusted. I know what I've put in there. I know that I'm going to load a file from a CDN. Well, I don't care where it comes from. I specified this, and this script tag is trusted. So if somebody would inject a script tag loading something from evil.com, he would not know the nonce, because the nonce is fresh and random. So every page has a different nonce, so the attacker has no way of predicting the nonce and injecting a script tag that would result in script being loaded. Very good. What's also good about nonces is that you can actually do that for inline script blocks as well. So now we actually have a way to mark inline script blocks as trusted. We can simply say script nonce is this random value, and even if the attacker manages to inject an inline script block, he will not have the right nonce and he will not be able to execute scripts, which is very powerful, makes CSP a lot better. This is version 2. This has been around for a year or two already, and already improves certain things, but it's not good enough yet. Because if you want to load something like this, a Twitter widget, well, it's easy enough. You need to include this one piece of script from Twitter, and then it starts loading all of these other things that needs to be loaded for the Twitter widget, which is unbelievable, by the way. You need to whitelist at least 6 or 7 things from Twitter to be able to get this working with CSP. Of course, here, we are again whitelisting CDNs, and we're still in trouble. Because again, this Twitter CDN hosts code that can be used to bypass CSP and result in cross-site scripting. So the solution that Google came up with, Google decided whitelisting doesn't work. They tried it for their services. They decided, well, with all due respect, it's a pile of crap, and it's not going to work for what we're doing. So we cannot use CSP like this, and that's why they proposed to use strict dynamic. A strict dynamic is a new keyword which you can add to your script tag. And what it essentially does, it tells the browser to trust a script when it's loaded, and what this means in practice. So scripts are trusted by this nonce, and once you've trusted a script, once you agree to put a script in your page, it can do whatever it wants. We talked about this before. It has full access to your page. So whether it wants to load some additional scripts or not, you already trusted the script anyway, so you might as well allow that to happen too. It doesn't really increase the attack vector, and it makes CSP a lot more compatible with your application. So essentially, by adding strict dynamic, if this is a Twitter widget, it would be allowed to load additional files from Twitter, and this thing will simply work just like that. And that's a very, very powerful addition to CSP, and this is something that makes CSP actually quite useful. So because of strict dynamic, Google actually proposed this sort of universal CSP policy, a CSP policy that works for every application out of the box, which is, again, very, very powerful. And it comes down to the fact that you have your nonces, you have your strict dynamic, and that's essentially it. These things are fallback mechanisms needed for older browsers, which I'm going to show you in the next slide. So this is universal CSP policy, non-strict dynamic, and some fallback mechanisms. This means that if you have a recent browser, like Chrome and Firefox, this is a policy that will actually be enforced. So you have your random nonces to mark scripts as trusted. You propagate trust once a script is loaded, so strict dynamic is there. And unsafe eval is to avoid errors. One of the dangerous features with CSP is eval, because some people put untrusted code into eval. It's not very common anymore. It's a more obscure attack vector, so they simply re-enable eval to avoid compatibility issues. So it's a small attack vector that's still left, but this offers you a great deal of protection against cross-site scripting attacks. You see there are all these fallback mechanisms, so what do they mean? This helps you protect against remote and inline scripts, by the way. If you have an older browser, like Safari or Opera, essentially you have this, they know what a nonce means, so they can enforce that. They don't know strict dynamic, so they're going to fall back to this very open whitelist for all HTTPS resources and all HTTP resources. So as you can imagine, if whitelisting was broken, this is again broken as well. So you don't get protection against remote script injections, but you get protection against inline script injections. So inline script blocks will still be blocked, but remote files will be able to be loaded with this. Then you have the other ones. They will enforce this policy, which essentially gives you nothing. It also doesn't break anything. So that's the good thing about this policy. If you deploy this, the smart users will actually get protection, and the other ones, they still have a working application, which is not more vulnerable than it was before. They simply don't get additional protection from this. By the way, Edge is moving up. It used to be here. In the next version, they will join this club here. So they have implemented support for CSP level 2, and additional support will be coming in the coming months. This is going to be big. This is something that makes CSP viable again, or finally.
Did you just say make CSP great again? Did you really just say that?
Yeah, something like that. Yes. Awesome. This is true, by the way. It's not fake news. All right. So a quick recap about CSP. This is the last real cross-site scripting topic, by the way. And after that, I'm going to move into session management. So CSP prevents injected scripts from being executed. It's very powerful. CSP also gives you control over all kinds of resources. You can restrict style sheets, restrict where XHR can connect to. You can restrict WebSockets. Plenty of options there. Again, more on that on Friday. This universal CSP policy is compatible with applications regardless of the browser they're running in, which is very good. So a really ancient browser simply ignores everything, and then you have this step-up mechanism where the modern browsers actually benefit from this protection. If you go look at Google services like Google Pictures or something like that, they actually have this policy in place now. So they tried it out and it works. So that's definitely a good thing. Something I didn't mention, CSP has a reporting mode, so you can allow CSP or instruct CSP to send you reports about potential violations. You can also instruct CSP to only send reports and don't block anything. So that's very useful to get some insights into violations. And again, CSP has other kinds of restrictions as well. Any questions about this so far? No? Okay, that's either really good or really bad. I'm going to go with the former one. So, stateless session management. We're talking about Angular applications. So we covered the cross-site scripting part. Well, to be honest, a lot of other security principles involve the server side as well. But session management is one of these things that has radically changed in client-side applications and browser-based applications. So we used to have server-side session management where all data was stored on the server, kept on the server, but modern applications try to move this to the client side. And this seems like a trivial choice, but in practice, it's going to be a bit more tricky than what you might think.
It seems like the wrong choice, right?
It depends. Depends on what you're running in the backend. Yeah, it's...
It depends if you want to invalidate sessions.
There's no right or wrong answer. I think it highly depends on the situation, and that's also going to be, I'm going to skip ahead, that's going to be my conclusion as well. You need to evaluate what matters for you and what works for you, which properties you want to enforce, and it's not all rainbows and sunshine, essentially. It's, yeah, they both have advantages and disadvantages. It's never a clear-cut decision like, do it like this. No, it depends, and that's where things get messy.
Sessions are pretty well understood, and there's taking a totally new approach where it's on the client side, where it's under the attacker's control is kind of like, from a security perspective, like I don't know.
Yes.
Maybe you can do it right.
I agree with you.
Yeah, you're absolutely right. One of the main reasons I go into this is because you find all of this information saying, yeah, move it to the client, JOT tokens are awesome, everything is secure. But a lot of people don't really know what's at play here. And we've covered this during the previous talks as well, and Jim has commented on that extensively. So there are some things you need to be aware of and things you need to keep in mind. And then you need to make your own decision, as always, about what you do.
Yeah, we've gone through the same thing in engineering, so
Yeah.
that is by experience.
So what are we talking about? What is this discussion? Obviously, these guys know a bit about what they're talking about. So let's inform you guys as well, so make it interesting. In traditional server-side session management, what happens is if you connect to a server, you probably all know this, right? This is cookies, session cookies. Your server generates a session, gives you an identifier, which is probably a bit more random and longer than this one, stores some data associated with it, and gives you the cookie. The cookie is sent to the browser, and the browser will actually store that for your domain. We covered that before. When you go back, the browser attaches this cookie, the server gets this identifier, looks up your session, sees that you're not authenticated, authenticates you, and sends you the response. Sorry. So this is server-side session management. Note that there's no update here. The server knows the ID, the browser knows the ID, server knows the session state. Why do people want to move to something else? Because this requires you to keep session state on the server. And for most applications, that's not a problem. But if you're running something that's kind of distributed and has a lot of different services, you need to find ways to either stick one user to one server or to share sessions between servers or things like that. And that's fairly messy, that's true. But as Ian said, it works quite well today, yet people are moving or want to move towards something that's easier. But the easier solutions have their drawbacks as well. People believe that client-side session management is the holy grail, that it fixes a lot of problems. So what happens there is if you visit a page, the server creates a session object. And instead of assigning an identifier, he simply puts the whole thing in a cookie and sends that to the browser. So you have the context on the client and you have the cookie here. When you go back, you send this data there. The server unpacks the cookie, looks at the state, sees that you're not authenticated, authenticates you, updates the state, and sends the session object back to the browser. So your session object is updated, the data is stored here. The good thing is you don't need to keep anything here. So you can restart your server, you can move your server to a different data center. As long as you update your DNS settings, when the user comes back, the server will know who you are and whether you're authenticated or not. This seems, deployment-wise, this is pretty awesome. No state, yay. Of course, security-wise, there are some changes here. So in server-side session management, what you get is you have a stateful backend. So indeed, you need to keep this state somewhere. You need to take this into account, and this generates a lot of load for your server. It also gives you full control over the session. You know how many users are active in your application. If you want to deactivate a user, you can simply remove his session state, and the user is unauthenticated. It's gone. It's unknown to the system. What you do here is you typically have a session identifier, which acts as a bearer token. So the one who has a session identifier will be able to impersonate you to the service. On client-side session management, it's stateless. So you have no state on the server, which is absolutely great. You also have no control over active sessions. First of all, you don't know how many users are active unless you start counting tokens with their expiration dates. So that's already fairly difficult if you even have tokens. That's one thing. It's very hard to log a user out forcibly because the state is stored on the client. So this would mean that I have to go to your computer and remove the session object from your browser to log you out, which is definitely not possible. And also, it makes the requests essentially a lot larger because you have to ship this data back and forth on every request. And one very important thing is it requires additional protection of the session data. So you can imagine in the previous image, if you store state like this on the client side, how easy it is for me to change this from false, if it says false, to change it to true, and to change the username there as well. So this data needs to be protected, and that's something that's typically done by adding a signature to it. So this thing becomes a lot more complex very quickly. So if I want to ship this to the client, it's the black cookie here, when I get it back, I want to make sure that the client has not tampered with this. I want to make sure that the data I put in there is still integer, that integrity is ensured. And you do that by adding, well, this is if you use cookies for this in one of the Express modules. They add this second cookie containing a signature. And it's essentially a signature calculated with a server secret over the session object here. And when you receive this, you receive both cookies. You can calculate a signature again and match it to this one. If it matches, then you know that someone who knew the secret has generated a signature. It should only be the server, by the way. So Bart has covered this with HMAX. If it doesn't match, then you know that this is not an authentic session object and you shouldn't be trusting this. But as you see, this becomes a bit more complicated. This thing is base64 encoded. It's not encrypted. You can simply decode that in the browser using the B2A function, I think, or the A2B. I always mix them up. But essentially, this is plain data. So this data is readable on the client side by anyone who can see that cookie. and the signature is generated with a server secret. So a lot of client-side applications, a lot of Angular applications actually start doing it like this. And you see cookies here. And if you were here in my talk on Monday on the security model of the web, you know that I talked about CServe. So if you were not here, well, maybe, was someone not here on Monday? Except for Ian, but I suppose you know what CServe is, right? So, all right. Quick recap. In a CServe request, the problem is when you make a request from a different context, the browser will attach the cookie here. So that's essentially the problem. The server doesn't know whether this is legitimate or not. He simply knows that you're authenticated, but doesn't know where this comes from. One of the defenses I talked about was the secret form token. So essentially, you embed this token into your HTML page, and you submit it again, and it's missing here because this context cannot access the token, so the server knows that something is going on. The problem is, in an Angular application, this is kind of problematic because you have these templates, you don't have a page with a form that will be submitted, so there's no clear flow. So this will definitely not work. This is not the Angular way of doing things. Let me skip ahead here. So the Angular way of doing things would be with a second cookie, because you put a token in a second cookie. The cookie is copied to a header here and can be checked by the server. This doesn't require any HTML code. It simply requires some JavaScript code running on the client, having control over requests, and essentially that's what Angular is. It's JavaScript code running on the client, so it can do this. And it actually does. So Angular supports this mechanism by default. If you use the right name, if you use this XSRF token cookie, the XSRF token cookie, Angular will copy this to this header. You can configure this, by the way. You can configure the name of the cookie and the name of the header if you want to. But by default, using this cookie is enough for Angular to copy that value on outgoing requests, just like that. So your backend still needs to enable this, but when you do it, your cookie-based session management is protected against CServe. I also talked about fixing cookies on Monday. So essentially, using same-site cookies would be a very good solution here. The problem is that not many browsers support it yet, so we have to wait for the future to be able to do that. Once we have this, we don't need to copy the tokens anymore. Everything is fine by default.
I'm not familiar with that. Same-site equals script.
That's something shiny new from, I think, a couple of months ago.
Oh, okay.
If I'm not mistaken, Chrome and Firefox support it, but the other ones not yet. So essentially what it says is it makes cookies first party only. So cookies will be attached from this context to this one, but when you come from another context, it's not there. There's a configuration setting, strict or lax. Strict means never send a cookie, and lax means only on navigation requests. So if you navigate the top level context, the cookie will be there, but not for cross-site requests. All right, so moving to client-side sessions, essentially it has changed the security properties, but we're still using cookies. That also has changed in Angular or in client-side applications. Instead of using cookies, people actually try to use different mechanisms. And there's this thing called the Authorization Header, which has been around for 30 years or something, that has been resurrected. So you probably know this from the username and password pop-up dialog, which is really ugly and doesn't work very well. Well, now it's being used for something else, so let's go into that. This header is typically used in combination with something called JSON tokens, which I'm gonna go into in a bit. What's the authorization header? For the young people in the room that may not know what this thing is from a long time ago. HTTP is stateless by nature, meaning if you have two requests going to the server, if I send one now, I get a response. If I send one in 5 minutes, the server doesn't know who I am. So there's no way to keep track of that. Session management fixes that, but before we had cookies, we had the authorization header. The authorization header, essentially, when the server says you're not authorized, you could log in with the username and the password. This is this pop-up box, which actually at our department, you actually see this at some servers, which is horrible because it doesn't support password manager or anything like that. So that's the side note here. So you can enter a username and a password, and then it will be sent to the server in this authorization header. So this is basic authentication with some encoded value. By the way, base64 encoding, this is simply username, password. Just like that, yes. And it's not encrypted either, it's base64 encoded, so anybody can read this. No, that's encoding. Bad developer. So again, what the problem with this mechanism, the browser keeps this for you and attaches this to every request you send to the server. So once you have authenticated, the browser will keep sending this over and over and over again. So you can imagine back in the day, this didn't happen over HTTPS either, so that's a very bad security practice. But the second problem is there's no way to log out. The only way to log out is actually shut down the browser, kill the whole process, and open it again, and then you are logged out of this. So this is an ancient technique that's not used that often anymore. Well, you see it in Windows systems. They have this NTLM scheme, which is used to authenticate to proxies or something like that. So it's not important. Today, people use it a lot, actually. Yes?
So the browser itself made sure that the header was added all the time? Or?
Yes. Yeah, this is a browser thing.
And recent browsers don't do that anymore, right?
I think they still do, yes.
Because I saw a great application that just stored the basic header in local storage and then added it. It's a great application,
well,
of course. But,
yeah. No, I believe it still does because, like I said, at our department, some ancient service still uses it and it works. So I haven't checked actually because.
I was just wondering why. I found an application that does.
Did they do it with basic and username password or with something else?
Yeah, basic.
That is absolutely insane.
Yeah.
Yeah, I want to talk more about that after my session. That sounds really interesting.
Yeah.
So today this header is actually used a lot in combination with things like OAuth and also for things like client-side session management. And the way they use it is, well, it's actually not a bad idea to do this. Why? Because on the web you have a lot of things called middle boxes. And middle boxes are devices sitting on the perimeter that actually scan network traffic and that also strip out things that they don't like. So if you create this new fancy session management header, a lot of devices on the web will not know this and will strip it out. And the authorization header is something that they actually know, so they will not strip that one out. So that's one of the reasons that they actually reused this header. What you include in this, so you have different modes. There's a new bearer mode that you can use for that, but what you include there is it's unspecified. So you can include whatever you want as long as you base64 encode it for URL safety. So the header looks something like this. It can be a JOT token. It can be an opaque OAuth token. It can be a username and a password if you really want to, but you shouldn't. Essentially, it can be anything. Yes?
There's an awkward technique to do logout in this case. You can just Ajax request with authorization header with the bad username and password, which will give you back a 401 challenge, hopping the login box.
Okay, and it drops the existing credentials from the browser? Okay, awesome hack.
Gross
yes.
that we have because
okay.
all of a sudden we're depending on this garbage again. So we have.
Yeah, but this one isn't managed automatically. So this one you need to do manually, as I will talk about in the next slide or something. But yeah, the basic header, okay, I didn't know about the Ajax hack, but yeah. So there's some kind of funky logout mechanism available if you really want to. So why am I talking about this? Why the authorization header? Because again, a lot of new applications start using it, but the properties are vastly different than the way cookies are handled. So cookies are handled automatically by the browser. They're domain associated. They're stored automatically, attached automatically. So everything is fine in cookie land. Authorization header, nothing is handled automatically. You need to get the token or whatever you want to send back to the server yourself. So the server needs to send this in a response somehow. You can send it in a response header, in a JSON body. You're open. You can do whatever you want. You need to store this yourself somewhere. So you need to make a very sensible decision if you want to use this authorization header. And you need to attach this information to outgoing requests. And that is a lot more messy than you might think. So it's trivial in an Angular application if you want to intercept certain calls. But it becomes difficult if you have DOM resources loaded by the browser. What if you have images sitting behind an authorization endpoint that are automatically loaded through an image tag? You're not loading images with XHR and putting the data in the image tag yourself. The browser does that for you. But the browser will not attach this authorization header with a bearer value. So there, you will need to find some in-between mechanism. You need to fetch everything yourself with JavaScript, or you will need a cookie or something additional to handle that kind of authorization there anyway. So this is something that a lot of people forget about. Maybe it doesn't even matter in a lot of cases where everything is public anyway. Well, the static code is public and the data is protected, but some applications definitely struggle with this and need to take this into account. So, I talked about storing session data. Well, there are a few options to do that here. So if you want to use the authorization header and you need to store the session information yourself, you can do it in memory. So you can simply load an application, log in, and keep the token in memory. This means that it's available to run in code only. So if you have another tab from the same origin, it will not have access to this token unless there's a relationship between both of them, but if there isn't, then there's no way to access it. It's not accessible to the entire origin. It also doesn't survive a page reload. So if you reload a page, if the user clicks refresh, then the token will be gone because the context is reloaded. So that might be a problem. And you can shield this from malicious code in a sense because the code needs to be running in this exact context to be able to steal it. And if you use something like JavaScript closures, it's even unreachable. It can be made unreachable for maliciously injected code. So a few drawbacks and a few advantages here. Session storage. It's a storage mechanism in the browser. It's simply key value storage. You have two options. You have session storage and local storage. Session storage is available to the entire tab or window. So every tab has its own session storage, which is good. It even survives a page reload. So if you reload a tab, the session storage is kept. So that's definitely good. Shielding is a bit more difficult because if you have code running in the same tab, it can read out your session storage, of course. If you have code running in a different tab, it will have a different session storage and will not be able to get the token or whatever that's stored in there. So that's also an option. And then the third option, local storage. I think this one is used by things like MailChimp, for example, because if you go to a new tab there, you have to log in again. So they apply something like session storage. Local storage is used more often. It's simply you put it in there and the whole browser, everything running in that origin can access it. That's great for usability because the user is logged in every tab. Even if he goes to a new tab, goes to this application, you will be logged in, which is good. Survives page reloads, but if something bad happens, if somebody runs malicious code somewhere in your origin, he can simply read out local storage like he could read out document.cookie before and steal all the data that's in there. So that's, well, again, if people ask me, what do I need to use? Well, it depends. What do you want to do? How big of a problem is it that if the user reloads the application, he's logged out? Maybe it's not a problem. In that case, go for that. So this is something that you need to make, or a decision that you need to make for your own context. And then a couple of words about the bigger picture, like cookies versus the authorization header. Which should you use for session management or to keep track of your user's identity? Well, again, it matters, or it depends on your context. So both of them can contain any kind of data. So in the cookie, you can put in whatever you want, but in the authorization header, as long as you base64 encode it, you can put in whatever you want as well. Cookies probably enable CSRF, so you'll definitely need to make sure that you protect against that. If you use the authorization header, you need to screw up really badly to enable CSRF because people need to be able to make calls to an API through your context because your context needs to attach the authorization header from JavaScript. So that's a win there. Cookies are always associated with one domain, while the authorization header is under your control, so you can attach it to any request you want to. Again, this gives you a lot of flexibility, and this is needs or requires you to do a dirty hack if you want to share your cookie across domains. Think about Google. If you authenticate to Google, you authenticate to one origin or one domain, but they actually want to share your identity across a lot of domains. So what they actually do is, when you log in, they make a lot of background calls to domains like YouTube and Blogger and whatever to share your session identity with that domain as well. So they allow YouTube to set a cookie for its own domain, so that when you're logged into Google, you're also logged into YouTube and all of these other things. You can imagine this is very messy to actually set up and get right. Cookies, like Jim said, you can mark them HTTP only, so they're not accessible to JavaScript running in your context or origin. Of course, script running in your origin can do all kinds of other bad stuff, so it's only a small protection or a small advantage that you gain there. While the authorization header there, the availability depends on the storage mechanism. So if you use local storage, you're in trouble. If you use in-memory, then you can actually hide it pretty well.
All right, Doctor. I think this is really interesting in that this is one of the reasons that backs up why we think stateless patterns tend to be more dangerous. Even if the double cookie submit pattern, which Angular uses for CSRF protection, this is compromisable even when you're using HTTP only cookies as part of that defense, right? Because we can then cookie flood and force, and since there's no server-side state, they don't even care or know that we changed that cookie value. So, and it's just another dink in the armor of a stateless pattern, and all the more reason to use authorization headers. I think.
The reason to use authorization headers, or are you for or against?
I'm for authorization headers. It's a little extra work, but I think overall it tends to be a more secure way to roll when you're doing stateless patterns. That's what I'm trying to say.
But where do you store your
I'm sorry?
where do you store your session data then?
Session storage.
Okay. Yeah. Sure. It's a trade-off.
You're right. It's not right or wrong. It's just trade-offs.
Yeah. You can use both, and especially if you need to load other resources from a protected endpoint, like images and style sheets and stuff like that, then cookies may be a lot easier. All browsers support cookies. One of the main reasons you want to go for authorization header is actually if you're also building clients that don't support cookies. Because if you're building a mobile client, a native client, where you need the same authorization mechanism or authentication mechanism, you definitely don't want to start implementing cookie support. That's very messy, and that's going to be a nightmare. So there, this kind of thing may be easier. Again, it depends on your context. So the advice here, unfortunately, I cannot give you one single piece of good advice. It requires careful consideration, and this becomes even more relevant in the next section when I talk a bit about JOT tokens. So what you definitely need to avoid is you need to avoid rushing the switch from server-side to client-side session management, because a lot of people will not think about it. They will have flags like admin is true in their server-side session management, which is okay. They simply move it to the client, and all of a sudden you're in a world of trouble unless you know what you're doing. So if you want to do this, integrity is absolutely mandatory. Confidentiality is something you need to think about. What do you store in your sessions? Do you store personal information in there? Then you might want to offer some encryption as well. Do you store healthcare information in there if you're building a healthcare system? Server-side session objects? Sure. Store whatever you want. Client-side session objects? Well, maybe you don't want to put some health records in there without using the proper encryption methods. Cookie versus tokens is the wrong question. In my opinion, the real question is cookies versus authorization header, because as we will see in the next part, you can put tokens in cookies as well. So that comparison is something you see a lot. It doesn't really make too much sense. And again, both approaches have their merits and drawbacks. It's up to you to decide how you deal with that. Any other questions?
Session storage is all across the tab, but it's also binding to the origin?
Yes, yeah, of course. Yeah. Session storage is first of all constrained by origin and then by tab. So yeah, absolutely. Thanks for the clarification. Okay, so let's say you want to go at client-side sessions. If you look for a way to represent session data, people are going to tell you need to use JOT tokens. JOT tokens are very cool, very hip. They're JSON, so everything is awesome, no more XML, so we definitely want to use something lightweight. If you look at the definition, JOT tokens, or actually JSON Web Tokens, are a way of representing claims securely between parties. So it's not a session management mechanism, it's simply a way of representing claims. And one of these claims can be your identity. So you could use them to represent who you are and give that to the server, so the server knows if I'm requesting my mails, he can check who is this guy. Okay, it's Philippe. Okay, I'm going to give him Philippe's mails and not someone else's. A JOT token looks very colorful because you have three parts in it. You have a header, a payload, and a signature. So essentially, the header looks like this, payload, and the signature. This is the important part. This is what a JOT token is all about. These are claims. These are the name of the claim and the actual value. You have some reserved ones like issuer and expiration date. And you have some, you can also add your own claims like name, admin, or whatever. These things are supposed to be there. They're standardized, so you know if you want to look for the expiration date, you know that it's gonna be in a field with the name EXP. And then you can add things like admin or whatever. The other two things are actually there to ensure integrity. So the signature is generated using a server secret in this case. It's an HMAC, so essentially you simply calculate a checksum of this combined with the secret, and only someone who knows the secret will be able to generate a valid signature. So if the server keeps the secret safe, he can calculate this when he receives a token from the client and see whether it matches the signature that was there in the token. The client cannot forge this unless he knows the secret that the server will use to verify the signature, which is what an HMAC system is built on. This thing is here for compatibility reasons, so it tells the server this is the algorithm used for the signature, and this is the kind of token that we have here. A bit on that in a bit, or more on that in a bit. So JOT is actually an open standard to exchange information. The main advantage of JOT tokens is an easy way to represent tokens. It's very compatible with JavaScript because it's JSON. You can easily parse JSON from JavaScript. And the content is base64 encoded, so there's no encryption by default. JOT tokens support various kinds of algorithms. You have support for encryption. You have different kinds of signatures. You have public key signatures. You have HMAC signatures. So there's a lot of options there, which actually allow for a lot of flexibility, but also make it a lot more complex. For example, HMAC signatures with a shared key are very useful if you have one application issuing tokens and receiving them and needing to verify them. That's a very simple use case if you build a small web application. That's all you need. If you're, for example, Google offering an OpenID Connect endpoint, OpenID actually uses JOT tokens. Google is not going to sign this with its own secret and then give you the secret so you can verify whether the token is valid or not. No. What Google does, it will sign a token with their private key, give you the public key, so your server, when it receives a token from the browser saying, here's a claim from Google that I'm Philippe@gmail.com, using the public key from Google, my server can actually verify whether that token is valid or not. And that's where the strength of these tokens lies in. So the fact that you can have shared tokens, that an identity provider can give you a token which you can use to provide your identity or to offer a proven claim of your identity to another service, that's really powerful. It's used a lot in backend architectures where you have microservices. One service needs to forward a call. The second service needs to know who the call is made for. Simply, the JOT token can be forwarded. The service can verify its validity and then make or process the call in your name there as well.
Phil, cue back a step.
Yes?
Please stop me if I'm interfering. I just want to emphasize again, signatures are not part of the JWT standard. You have plain text JOTs or algorithms.
Yes,
algorithms none. You have to explicitly do the signature.
I knew this was coming, so I looked it up.
Which involves key management, which a lot of people don't do, and suddenly you've undermined your whole client-side security.
Yes, so
just make sure you do signatures is all I'm saying.
I knew this was coming. You're a bit too soon. Let me.
I don't look at libraries. I'm reading RFCs, so I'm sure some libraries are.
Yes. So I'm going to give you some best practices I took from a blog post. Essentially, there are RFCs, yes. You have the JOT RFC, and then you have all of these additional things. So you're right in the sense that JOT...
I didn't hear that. What was that?
You're right. Okay, so the JOT RFC covers the middle part of the token. It covers the claims. It specifies which claims are reserved. It specifies how they should be represented, how you should handle them. It also refers to these other specs. So it's true, there is a way to offer JOT tokens without signatures. It also says in the RFC, don't do this. It's definitely not a good idea to do it. And it refers you to the web signatures spec, which actually describes how the signatures are generated, what you should take into account so that every implementation of this is actually interoperable. You have a specific RFC for encryption, because encryption is, again, something entirely different. So they specify exactly how that needs to be done, what the available options are. There's a spec to represent keys in a JSON format, and there's a spec which defines all the algorithms that are available and how they should be implemented specifically using cryptographic properties. So if you want to know more about this, talk to Bart. He's the crypto expert on why this all matters. So, the important thing to know here is that a JOT represents data, not a transport mechanism. So again, if somebody says cookies versus tokens, you can simply say, dude, that's not okay. Go on YouTube. There's this secappdev lecture about single-page application security. Check it out and come back to me after you have done that. So JOT tokens can be put in a cookie. Sure, there's absolutely nothing to stop you from putting that in a cookie and dealing with it like that. It's often used in the authorization header. So Angular, people building Angular applications often put this JOT token in this authorization header with a bare practice, and they send it like that. Very useful to pass around, but again, this doesn't matter whether the server got it from a cookie or from a header. It's simply the fact that a JOT token is signed and represents claims that makes it easy to pass around. So to conclude, I want to go over this blog post from a month ago about best practices for JSON Web Tokens. So this is somebody who has a lot more time than I do to write all of this out. It's actually a very useful blog post. And I want to highlight some of the points in there because, it's not too elaborate, so some clarification may be useful for that. Actually, very valid advice in there. Best practice number 1, learn about underlying security properties. A lot of people think that JOT tokens are very easy to use and you don't need to worry too much about what you do and how you do it. Well, that's not very true, in the sense that they standardize the format, but you still need to make a conscious decision about what kind of signatures will you use. Will you use public key or private key? Will you use an HMAC? Do you even know what that means? Well, if you don't know what it means, you're not going to make a conscious decision, and that's definitely a problem that still remains, and that still requires you to know a bit about what these things mean. That's exactly why you're at secappdev. Once you've been here, you'll be able to make that choice in an informed manner. There's plenty of options. I only highlighted a few. There's plenty more, so definitely dig into that to know what they mean. You don't need to be an expert. You don't need to know exactly how an HMAC algorithm works, but you need to know what its properties are. What does it do? You need to know about the fact that you need to share the secrets with other parties to be able to do that. So if you want to use an HMAC and start sharing that with third-party services, you're in trouble. So you should use public and private keys for that. These things you need to know. Libraries, some of them make choices for you. It never hurts to do a sanity check. It never hurts to see what are they doing and does that even fit my situation. Very important advice. Step number 2, or best practice number 2, don't go overboard. Don't make it more complicated than you need, than it's needed for your application. It's like keep it simple, whether you want to add an additional S there or not, that's up to you. So select the simplest option that meets your needs. Concrete guidelines that you can use there. Don't store data you don't need in a JOT token. It only makes the request larger and it increases the attack surface. If you don't need confidentiality, don't bother with encryption. Don't make it more complicated than it needs to be. If you don't only need to store some identity information that nobody cares about or that's not very sensitive, an HMAC suffices. Most simple services get around with an HMAC with a secret key to generate the signature. Public key-based signatures, very useful in large distributed setups, very useful for things like OpenID Connect. For most applications, probably overkill. Definitely something to keep in mind. That's some valid advice there. Key management has been mentioned before. You need to plan this out.
Sorry, I have a question about that.
Yes.
So why would you encrypt that all? I mean, if you're going over an HTTPS connection?
Because the tokens are typically stored on a browser, in a browser.
Oh, yeah, okay.
So if you store plenty of tokens with a lot of sensitive information, if somebody steals it from your machine, you might leak stuff you don't want to leak. So it's not used that often. But if you're dealing with healthcare records or with the GDPR, this is something you definitely might want to take into account. All right. So when you start using keys, you run into things like key management, questions that you might want to think about up front and not after the fact. So things about what will happen if you want to switch your key? How would you deal with that? Do you need to keep the old key around? If so, what happens if the key is compromised? Should you start with 2 keys up front? Things like that are fairly difficult questions to answer, but you need to think about this up front. It doesn't suffice to simply encode one random secret and keep using that for the next 10 years. That's not going to work. and that allows people to do these cryptanalysis attacks that Bart will cover in a lot of detail in his talks. Keys should be rotated frequently. That goes out of my realm of knowledge. It's crypto stuff, so you need to figure out how frequently this needs to be done. This has to do with how much data has been encrypted with the key before it becomes possible to extract the key from a lot of plain text and encrypted data. But again, if you need to think about these things when you start using JOT tokens. So maybe client-side session management isn't so good after all, but that's something that a lot of people simply brush past because JOT tokens are very cool to use and everybody needs to do it. One of the stranger pieces of advice in the blog post is the fact that he advises to use, or the guy advises to use headless JOT tokens. And headless JOT tokens are, well, actually the advice comes from a very specific problem you have with JOT tokens. The whole token is untrusted, but as I said in the beginning, well, I repeated the slide here. So the whole token is untrusted, including the header and the signature. But the server needs to verify that anyway, and that causes problems. And it has caused 2 very real vulnerabilities in most JOT libraries in 2015. This was a major, major problem. First of all, many libraries accepted the non-signing algorithm. So you could simply create a JOT token in the beginning. Well, let me go here. In the header, you could say algorithm none. You could provide a payload, and then, of course, an empty signature. And the server, depending on this data to verify this signature for the whole JOT token, would simply verify it. The library would be like, okay, sure, algorithm none, let me look it up. Oh, I don't have to do anything. Okay, here's the token, proof verified. Done. Yeah. After the fact, it's like, yeah, come on, what were we doing? But yeah, this happens because there is actually a lot of choice here, and you don't always know upfront what kind of algorithm will be used. And people just overlooked it, and it became a vulnerability. The second part is a bit more complicated, so I'm not going to go explain this in detail, but it came down to the fact that you could trick one of these libraries to use a public key as the secret for the HMAC function. So you could, again, construct a token. If it used a public key to verify an HMAC signature, well, to verify signatures, if you specified the HMAC algorithm, it would use the key here as a secret, which, of course, it's a public key. You know it as well, so you can start forging signatures. So that's why the advice here is use headless tokens. And headless tokens is essentially a JOT token without a header. It's not a valid JOT token anymore, but if you simply send this to the client and append this statically on the server because you know what algorithm you're going to use, then you lose these potential attack vectors and you gain a little bit in security. A little bit in security, not insecurity. So essentially, what it comes down to is you remove the header before you send the token to the client and you append it again when you receive it. Of course, this only works for your own servers. It doesn't work when you're trying to build services that you need to share. So if Google would strip this from their tokens that they're issuing, then you don't know how to verify them. So you definitely need, well, this only works in an isolated service, but it doesn't hurt to do it. It also makes the request a little bit smaller. So that's definitely one potential way of avoiding future issues like this. But I'm pretty sure that the libraries have been vetted for additional problems here. Yes?
How did they solve that? I mean, they just ignored the non-signing algorithm, or? I mean,
Yes.
It seems a problem with the standard also, but I mean, if none is a valid algorithm.
Well, TLS also supports modes without integrity or confidentiality or authentication. So yes, it's a problem. I'm not sure why they're in there, but they're in there for a reason, I suppose. But so they fixed libraries to not accept none anymore. And for this, they actually, they avoided, well, they made sure that if you verified it, you need to make the distinction explicitly between an HMAC and a public or private key check, something like that. I think, I'm not entirely sure. I should look up what the fix exactly was, but it was a programmatic solution. It was
kind of the same problem, right? It's just changing the algorithm inside.
Yes, yes. Yeah, except that these are valid choices. So they made sure that the distinction was explicitly made on the server. I'm not exactly sure on the details anymore. It's been a while. But it's in 2015, but the warning is still on the JOT side that you need to update your libraries. Because if you have an application from before that, you haven't updated your node dependencies, then you're still running vulnerable software. Number 5. This is, again, way out of my depth of knowledge. Encryption and compression shouldn't be used together. It results in some practical attacks on cryptography. So if you're using compression, which is also supported, you need to do some padding and stuff like that. Again, want to know more about encryption and compression problems, talk to Bart. Best practice number 6. what about lifetimes and revocation? So how do you handle that? It's especially problematic if you issue JOT tokens with a lifetime of 5 minutes, it's not going to be a problem. But if I give you a token that's valid for 5 months, what happens if you get compromised tomorrow? I don't know where the token is. You have it, but I know that a few users have been compromised. I want to revoke access. I want to reset their sessions. There's no way for me to do that. So that's definitely problematic. That's an argument that a lot of people raise when JOT tokens are discussed, like, yeah, there's no revocation, client-side session management sucks, you shouldn't be using it, blah, blah, blah. Yeah, they're true in a sense, but it is possible. It only results in the fact that session management becomes a bit less stateless. So you need to keep some state on the server, but there's another way, well, there are various ways to do that. So one of the ways that's often recommended is to keep a blacklist of tokens that should no longer be used. So you should embed an ID in a token and then simply keep a blacklist, and you can check a token whether it's still valid or not. I'm not so sure whether this is good advice, in the sense that you need to check the blacklist, sure. If you're going to do something with revocation, you're always going to need to check something. But you need to know all of the JOT identifiers up front if you want to blacklist a couple of them. So I'm not sure where this comes from, or whether Ian or someone else has some input on this, but it seems a bit insane to me to do it like this.
I second that.
Yeah.
It's not secret.
The also good thing is the blacklist does not need to be permanently maintained. You know, especially if you have unique IDs, the blacklist only needs to be maintained for each item for your maximum session length time.
Yeah.
So the blacklist in some places that starts to, especially for a heavily hit service, if you're maintaining a permanent blacklist, that becomes a problem like CRLs. So
Yes.
you need to prune that blacklist based
Yeah.
on your max session time.
Well, actually, I was thinking about this, and I actually have a proposal that may be a lot easier to do. I haven't tested this. I just want to bounce the idea and see what you guys think. So what I would do is I would simply keep a counter value for each user. You start at 0, and you embed the value in the token. When you get a token, you check whether the counter is still the same as you stored in the database. And whenever you want to revoke something, you simply increase the counter. So every token with the counter value 0 that you get is no longer valid because my counter value is at 1. You issue a new token with value 1. And then again, the user comes back with a token, you check the counter value. Is it 1? Okay, it's the last seen counter or the last valid counter, that's fine. You want to revoke again, you increase the value again, and the token still, again, becomes invalid. And it doesn't matter how many tokens are issued, doesn't matter how many devices or how many users you have, you simply need to store one counter value for each user, and you're done with it. So let this sink in for a minute. I'm not saying this is good advice. I'm saying that it would make revocation, in my opinion, a lot easier than keeping a blacklist of identifiers for all kinds of tokens that may have been issued. We can discuss this.
We investigated a sort of similar but different way. We just invalidate the JWT by changing the signature on it. You know, so we'd actually just, you know, as soon as we wanted to blacklist somebody, we would change the JWT signature to no longer match.
But how do you change the signature of client-side tokens? You change the key? We had separate keys for every. Okay, if you have a key per user, yeah, that definitely works. You can simply rotate the key, and that gives you the same result. But of course, that requires you.
Another way, it's a bad way of invalidating the session.
Well,
I mean, it works.
yeah, sure. Of course, that requires you to keep one key per user. That crossed my mind as well, but that might be a bit heavy as well.
I really want to. This looks so simple. I really want to understand what you're doing here. It's not sticking in my head. Can you give me more on this?
Yeah. So
Walk me through it a little slower.
can we take it offline, maybe, or because time's up actually.
For it now, but I can wait.
Okay. Let me quickly run through it once again, and if there's any discussion, we can have it after the talk. People can join up here, and we can have a nice closed session. So what you should do is, when you have a user in your system, you keep a counter value in your database. Like instead of a blacklist, you simply store JOT token, JOT counter 0. And you embed the counter value in the token, and you send it to the client. Whenever the token is sent back to the server, you verify the signature, of course, and then you check this counter value. Is this the counter value that's stored in my database, yes or no? If it is, then you know that this is a valid token. If it's not, well, if it's the counter value in the database is, let's say it's 6 by now, because I have.
When you increment the counter every login?
Yeah, no, you increment the counter if you want to revoke tokens for a user. Let's say that your counter value is 0. Yeah, you have tokens on all your devices. You can access my service.
With the web, with mobile, and
Yeah.
I use the same counter for every device.
Well, the counter is in your JOT token, so it's simply there. Doesn't matter. But your account is compromised all of a sudden, and I want to revoke access to everybody except the real gym. So I up your counter to 1. So your attacker comes to my service. He has a token with counter value 0. My service says, oh, no, this is no longer valid. You come to my service, your tokens have a counter value 0. My service says that's not valid, please log in again.
So this is not log out, this is revocation.
Yes.
Like, I can't, what I'm trying to do is, suppose I log into my mobile on the web, and I want to log out of the mobile app before the token revokes, before the token is invalid. If I revoke it at the mobile level, then all of my clients get revoked.
Yeah, so that's...
It's not log out.
No, it's revocation, yeah.
Okay.
If you want to do logout, you can simply remove the token on a device.
I mean, you basically reduced it to a 1-bit.
I got you.
Yeah, and you don't need to, because the problem with these identifiers is if you want to revoke after the fact, you need to know which identifiers have been issued. And like you said, it's going to be a huge list. So you need to keep both a list of issued identifiers and a blacklist. And well, of course, it's only, again, 1 bit of information, but it's a lot more insane to keep that than to do it like this, in my opinion. But we should talk this through after the session. I have 3 more slides, so bear with me. The last thing, well, we actually did this already. There's plenty of RFCs. They all have security considerations, things you need to take into account. Take some time and read them, understand the differences between JOT tokens and cookies, and make educated decisions. So,
Did you just compare tokens and cookies?
sorry. Yeah, that is definitely not okay. My apologies for that.
You just
Yeah, I will have to fix that in the slides. I will do that after my talk. So again, this is what we talked about before. It's a standardized way to represent data. It can be transmitted using HTTP headers or cookies, which is essentially also an HTTP header. And they don't make things easier. They just make it different, make it maybe more standardized, but you still have some things you need to take into account. So that's what we talked about here today. So we started with cross-site scripting. Essentially, Angular has your back. Just get out of the way. Don't do trust as whatever. It's not a good thing to do. Make sure you understand that the templates are actually compiled by Angular. So once there's untrusted code in there before compilation, it's game over. You're done. Angular 2 has your back there with ahead-of-time compilation. CSP, very compatible with Angular applications, especially the new strict dynamic feature from Google. Very recommended to start using as soon as possible. And then you have session management, which is definitely difficult. JOT tokens are not necessarily evil. They're a totally new paradigm. So you need to be aware of what you're doing there if you really want to start using these things. And then, of course, my conclusion slide. You're going to see this again on Friday. Build secure applications. You're the guys doing that. You guys have the power to do that. Follow the people that know about this. Stay up to date with news like these JOT best practices. Think about them and share your experiences of what you have here. If you want to know more, there's a security course I'm running in April. And that's it. Thank you very much. If there's any more questions or discussions, come to me. I still can hold up for like 10 to 15 minutes and then I have to go to the bathroom, but that's okay. Enjoy coffee.